Hey guys, happy Monday. So today we're going to be talking about the unit circle again. The unit circle is extremely important moving forward, so I want to make sure that you really have a good understanding of what values go where before we move on. So today, you're going to print out this worksheet and fill it in as you're watching the video as I'm doing this. I have another unit circle here. I have 2 pages of the unit circle. Some of my work I'm going to be showing on the second slide just to make it a little bit easier to follow. You can show your work on a separate sheet of paper. You can print out 2 unit circles, whatever you think works best for you. So, some basics about the unit circle and about the coordinate plane in general that we have to know. First is where our quadrants are. The quadrants are very important because different trig functions are positive and negative based off of which quadrant that they're in. So starting in the top right corner, we have quadrant 1, and then from there we move counterclockwise. So top left is quadrant 2, bottom left is quadrant 3, and bottom right is quadrant 4. Now we know from the last lesson, very important, when we're talking about sine and cosine and we're looking at the unit circle, they're represented by different variables. So we know that the cosine of a function, or cosine of theta, is represented by our x, and the sine of theta is represented by the y-coordinate on our unit circle. And an easy way to remember that, if you're forgetting, think about an ordered pair. Our ordered pairs are always x, comma, y. X and y are in alphabetical order. So if you think about your cosine and sine as an ordered pair, it's always cosine of theta first and then sine of theta, because that's also in alphabetical order. So based off of the quadrants, we know if sine of theta or if cosine of theta is positive and in which quadrant it is. So if cosine of theta is represented by x and sine of theta is represented by y, we know that both have to be positive in our first quadrant because that's our positive x-axis and our positive y-axis. So positive in our first quadrant is sine of theta and cosine of theta. For now, we're just talking about sine and cosine, so nothing is negative. Nothing actually is ever negative in our first quadrant because x values and y values are always positive. In our second quadrant, now, in the second quadrant, we've moved into the negative side of our x-axis, which means then that cosine is negative, but sine stays positive because we're in the positive y-axis. So for quadrant 2, sine is positive. So sine of theta is positive and cosine of theta is negative. In quadrant 3, now cosine or x values are staying negative, and our y values now we're in the negative y-axis. So both sine of theta and cosine of theta are going to be negative. The only thing that's positive in our third quadrant is the tangent of theta, which we haven't talked about yet, so don't worry too much about that, but just know for future that tangent of theta is going to be positive in the third quadrant. And finally, the fourth quadrant. In our fourth quadrant now, we're back in the positive x values and negative y values. So positive x, negative y means that the cosine of theta is positive and the sine of theta is negative. Now there is an acronym that you can use to remember what trig functions are positive in your unit circle and where. And I'll tell you that now. It's going to be good, very helpful future. It is starting in quadrant 1, A, quadrant 2, S, quadrant 3, T, and quadrant 4, C. And we can read that as all students take calculus. That's what's going to help you remember this acronym. All students take calculus. It matches up exactly with your quadrants. And A, All means that all of your trig functions are positive in the first quadrant: sine, cosine, and tangent. S, students, represents sine, so the only function in the second quadrant that's positive is sine. Take represents tangent, so the only positive function in the third quadrant is tangent. And calculus, C, represents cosine, so cosine is the only positive trig function in the fourth quadrant, and that's going to be very, very helpful for you in the future. So that's how we know our quadrants and which of our functions are going to be positive and where. We also know we can fill in the middle of our axis with degrees. So easy to start. We can start over here on the positive x-axis. We know that's 0 degrees. That is our initial side, so that always starts at 0 degrees. Moving over to our positive y-axis, now we've gone 90 degrees. So this is 90 degrees. Moving another 90 degrees, now we're on the negative x-axis. That's 180 degrees. So we formed a straight line. And then on the negative y-axis, we have positive 270 degrees. And then we can complete our full circle by going back to the positive x-axis. And under 0 degrees, we're going to fill in 360 degrees. Because our positive x-axis represents an angle of 0 degrees and an angle of 360 degrees. Those angles are coterminal. We're also able to, using our axis, fill in these coordinates to understand what our sine and our cosine are at these points. So the point on our unit circle is what's going to tell us what the sine or the cosine of this angle is. This point on the x-axis is at 1, 0. So the cosine of 0 degrees is 1, and the sine of 0 degrees is 0. Moving to the positive y-axis, for 90 degrees, this point on the y-axis, this point is at 0, 1. So at 0, 1 for 90 degrees, the cosine of 90 degrees is 0, the sine of 90 degrees is 1. On our negative x-axis, we have negative 180 degrees. Our point, our ordered pair, is going to be at -1, -1, 0. So the cosine of 180 degrees is -1. The sine of 180 degrees is 0. And finally, for our negative y-axis at 270 degrees, our ordered pair is 0, 0, -1. So the cosine of 270 degrees is 0, sine of 270 degrees is -1. So that's always the easiest thing to fill out on our unit circle. We know the degrees of the angles based on the axis, and we know the points on our x and y axis, which tells us the sine and the cosine of those angles. So if ever you're trying to find the sine or the cosine of an angle and it is divisible by 90, then you know it either lands on the x or the y axis, and you can use these coordinates to easily figure out the cosine and the sine. Angles other than that are not divisible by 90, we have to start using our special right triangles. So first we're going to start with our angles of 45 degrees in our unit circle. So we can fill in each quadrant, we know represents obviously 90 degrees. So our 45 degree angle is going to be splitting the quadrant exactly in half. So in our first quadrant, our x-axis is 0. This line in the middle, that's splitting the quadrant exactly in half, is going to represent your 45 degree angle. So this is our 45 degree angle. From that angle, if we add 45 degrees, then we make it to the positive y-axis, which is 90. If we add 45 degrees again, then we get to the middle of our second quadrant, which is represented by a 135 degree angle. 90 plus 45 gives us 135. If we add 45 again, we are at the negative x-axis with 180, add 45 again, and we are split exactly in between the third quadrant, which is 225 degrees. And add 45, we are at the negative y-axis at 270 degrees. And finally, add 45, we're directly in between the fourth quadrant, which is 315 degrees. And I'm starting with our 45-degree angles, or our angles that are divisible by 45 degrees, because these angles are a little bit easier to work with our 45, 45, 90 triangles than the 30, 60, 90 triangles, because two of the legs are always congruent, because it's an isosceles triangle. So we're going to start, I'm going to move on to this blank unit circle to make it a little bit easier. We're going to start in our first quadrant, where we have our 0 x-axis, we have 0 degrees and 90 degrees, and we just filled in this as 45 degrees. So using this information, we're able to create a 45, 45, 90 triangle using this terminal side of our triangle, and coming straight down from that point on our unit circle. So here we've created a right triangle. We know that our reference angle, we call this the reference angle when we're using our x-axis, is 45 degrees. And our angle up top here is also 45 degrees. Now we know in our unit circle the hypotenuse, or the radius, is always 1 unit, which means in our 45, 45, 90 triangle, using the rules of special right triangles, that the x value is radical 2 over 2, and the side, the y value, is also radical 2 over 2. These sides are always going to be congruent because it is an isosceles triangle. The sign of these sides, though, depends on which quadrant you're in. So because this base side of my triangle, we're moving in a positive direction, so it's going to be positive radical 2 over 2, and then we're moving up, which is positive for y, radical 2 over 2. So our ordered pair at this point is radical 2 over 2, radical 2 over 2, and I'm going to fill that in on my original circle. So I fill that in here for my 45-degree angle. I have radical 2 over 2, radical 2 over 2. So cosine is radical 2 over 2, sine is radical 2 over 2. Both are positive because we're in the first quadrant. Now, if we flip this triangle over my y-axis to get to my 135-degree angle, so here in the middle is my 135-degree angle. Now we can use the same exact rules for this one. This angle is divisible by 45. So I'm going to draw my right triangle again using the terminal side. Coming straight down from that point on the unit circle, and then my base. So here I have, again, a right triangle. The reference angle, which is here, with my x-axis, is 45 degrees, and this angle at the top, again, is 45 degrees. We know, based off of rules of special right triangle for 45, 45, 90, if the hypotenuse is 1, which it is always in our unit circle, then our legs are going to be radical 2 over 2, and radical 2 over 2. However, because we're in the second quadrant now, our signs could change. So for x values from the origin, we're moving to the left. This side of our triangle is on the negative x-axis, which is going to make this negative. For my other side, I'm in the positive y-axis, so that's going to stay positive. So my coordinate here, at this point on the unit circle, is at negative radical 2 over 2, positive radical 2 over 2. So if I fill that in on my unit circle, for 135 degrees, I have negative radical 2 over 2, radical 2 over 2. So my cosine is negative and my sine is positive, which matches up. S, remember quadrant 2 is S, students. So only sine is going to be positive in the second quadrant. And I can do the same thing 2 more times with my other 2 angles that are divisible by 45. So if I move into the third quadrant, my angle here is 225 degrees. We're going to make our right triangle using the terminal side. So we come all the way out here to the point on the unit circle and connect it to the x-axis. So again, we have a 90-degree angle here. Our reference angle is 45 degrees, and this angle at the top is 45 degrees. So looking at this, we know that our legs have to be radical 2 over 2. We just don't know the sign based off the quadrant. So from the origin, we're moving on the negative x-axis, which makes this leg of our triangle negative radical 2 over 2. That's our x value. For this leg of our triangle, we are moving in the negative y-axis, so it's also going to be negative radical 2 over 2. So our ordered pair here for 225 degrees is going to be negative radical 2 over 2, negative radical 2 over 2. So I'm going to fill that in on my original unit circle. At 225 degrees, I have negative radical 2 over 2, negative radical 2 over 2. So my cosine and my sine of 225 degrees are both going to be negative, which matches up with my acronym. In quadrant 3, it's take, so only tangent is positive. Cosine and sine are both going to be negative. And finally, for the final angle, in quadrant 4, it's 315 degrees. And I'm going to use this terminal side to create the right triangle. So I have my 90-degree angle here. My reference angle here at the bottom is 45 degrees, and this angle up top is also 45 degrees. The legs are radical 2 over 2. I'm moving on the positive x-axis, so x is going to be positive radical 2 over 2, and on the negative y-axis, so that's going to be negative radical 2 over 2. So my coordinate at this point, at 315 degrees, is positive radical 2 over 2, negative radical 2 over 2, based off of that coordinate. If I fill it in on my unit circle here, at 315 degrees, I have positive radical 2 over 2 for cosine, and negative radical 2 over 2 for sine, which keeps up with our signs based off of which quadrant we're in. So that's for your 45, 45, 90 triangle. This you're going to use for any of your angles that you're given that are not divisible by 90 but are divisible by 45. So you can always use your 45, 45, 90, your rules of special right triangles to figure out these sides. And your legs are always going to be radical 2 over 2, just the sign is going to change based off of which quadrant that you're in. The remainder of our unit circle we're able to fill in using 30, 60, 90 triangles and the rules for those special right triangles. So we have 8 additional angles in this unit circle that we're going to fill in using the rules for 30, 60, 90 triangles. So the closest angle here to 0 is obviously going to be our 30-degree angle. So we have 30 degrees here, and then we have 45, which we did before, and then the third angle in the first quadrant is going to be 60 degrees. From there, if we add 30, we've made it to the positive positive y-axis, which is 90 degrees, and then add another 30, and we've come to 120 degrees. Add another 30. So that's our angle here for 120. Add another 30, and we're at 150 degrees. And then 30 more brings us to the negative x-axis, which is 180 degrees. From there, if we add 30, we make it to 210 degrees. That's this angle here. 210 degrees, and then add another 30, and we're at 240 degrees. Adding 30 brings us to the negative y-axis, which is 270 degrees, and then finally the last two angles are in the fourth quadrant. So if we add 30, we are at 300 degrees, and then 30 more gives us 330 degrees. And then finally, if we add 30, we're back to the positive x-axis, which is 360 degrees. So we're able to use our 30, 60, 90 triangle to figure out the coordinates on each of these angles. And this one's a little bit trickier than 45, 45, 90 because your coordinates will flip based off if it's a 30-degree angle or a 60-degree angle. But let's start by looking at our 30-degree angle. So we have this unit circle. I've left most of it blank so that it's easier to see the work, and we're going to start in our first quadrant with this 30-degree angle. So we're using the same logic that we've been using for our 45, 45, 90 triangles. Now it's just a different right triangle. So I'm going to draw my triangle using my terminal side and bring my side straight down from that point on the unit circle. So here's our right angle. We know, because this is a 30-degree angle, obviously, this one's pretty easy, that our reference angle is going to be 30 degrees. We also know for sure that the hypotenuse is 1. The hypotenuse is always 1 because the radius of our unit circle is 1. If the hypotenuse of a 30, 60, 90 triangle is 1, then we know that the shorter side, which is across from the 30-degree angle, is 1 over 2, and the longer leg, which is across from the 60-degree angle, is radical 3 over 2. That stays true for all of these triangles when the hypotenuse is 1. So my ordered pair for this point on the unit circle, I'm in my positive x-axis, so that's positive radical 3 over 2, and positive y-axis, so that's positive 1/2. So as always in the first quadrant, everything is positive. So my cosine of 30 is positive 3 over 2, and the sine of 30 is positive 1/2. And I'm going to fill that in on my unit circle here. So I have positive radical 3 over 2 and positive 1/2 for my cosine and sine of a 30-degree angle. Now moving on to the other triangle that we can create in the first quadrant, that is a 30, 60, 90 triangle using our 60-degree angle. So now it's a little bit different. I'm creating this right triangle using the terminal side. I'm bringing it straight down to create my right triangle. So my hypotenuse is the same always, it's still 1. But now this reference angle, the reference angle of the right triangle that I just created is 60 degrees. So this reference angle now is 60 degrees rather than 30 degrees. And this angle at the top then has to be 30 degrees. The only thing that happens when you switch your reference angle from a 30-degree angle to a 60-degree angle is that your legs flip. So you'll see in the triangle that we just did, where 30 was the reference angle, across from 30 was 1/2, across from 60 was radical 3 over 2. That is always true for these triangles where the hypotenuse is 1. Because we have a 60-degree reference angle now, our sides just flip. So in this triangle, across from my 30-degree angle is going to be 1/2. And across from the 60-degree angle is going to be radical 3 over 2. And I'm going to draw that at the top here, so if it's a little bit difficult to see. So I have my right triangle here. my reference angle is 60 degrees. This angle here at the top is 30 degrees. Hypotenuse is always 1. Across from the 60 degree angle is radical 3 over 2. Across from the 30 degree angle is 1/2. So my coordinates here, all they're doing is flipping because it's a 60 degree reference angle now. So the coordinates for my 60 degree angle are going to be 1/2, comma, radical 3 over 2. Everything stays positive because we're still in the first quadrant. So if I fill this into my unit circle, I have 1/2 radical 3 over 2 representing the cosine and the sine of a 60 degree angle. And that pattern is going to stay the same throughout this entire unit circle. So it's easier to remember. Anytime you're given an angle that is divisible by 60, then your reference angle is going to be 60 degrees. For example, if you're given an angle of 120 degrees, 120 degrees is divisible by 60. So we know for sure that the reference angle is 60 degrees. Reference angle in that case has to be 60 degrees. If you're given an angle that's not divisible by 60 but is divisible by 30, then your reference angle is 30 degrees. For example, if you're given the angle 150 degrees, 150 is not divisible by 60, but it is divisible by 30. If it's divisible by 30, then we have a 30 degree reference angle. So that's going to make it a little bit easier to figure out what the sides of your triangle are going to be. So if we try to draw this angle in our second quadrant for our 120 degree, 120 degree angle, I'm going to draw my right triangle using the terminal side and bring it straight down to my x-axis. Now, like I just said, 120 is divisible by 60, so that makes our reference angle 60 degrees. We know for sure that our reference angle is 60 degrees, which means that this angle at the top is 30 degrees. In these special right triangles, the hypotenuse is 1, so directly across from 60 is going to be radical 3 over 2, and directly across from 30 is 1/2. Now, because we're in the second quadrant, we are moving to the left of the origin, which means our x values are negative. So cosine in this case, or the x value, is going to be negative 1/2. 3 over 2, our y value, is still in the positive y-axis, so it stays positive 3/2. So this coordinate here for 120 is negative 1/2 for my x value, positive radical 3 over 2 for the y value. So if we add that into our original unit circle, for 120 degrees, we have negative 1/2 for the x value and positive radical 3 over 2 for the y value. So cosine of 120 is negative 1/2, sine of 120 is radical 3 over 2. And this pattern continues throughout this triangle. So I'm going to erase part of this triangle now so it's a little bit easier to see, and we're going to work with 150 degrees. So I've erased part of my triangle here in the second quadrant. We just talked about the 120 degree angle. Now we're going to talk about the 150 degree angle. So for 150, I'm going to make my right triangle using the terminal side. Bring my side straight down from that coordinate and complete the right triangle. So we have our right angle here, right on the x-axis. 150, remember, 150 is not divisible by 60, but it is divisible by 30, which tells us that this reference angle here has to be 30 degrees, and this angle at the top is 60 degrees. So we know using our special right triangle rules, when the hypotenuse is 1, the side directly across from our 60 degrees is radical 3 over 2, and the side directly across from our 30 degrees is 1/2. Now again, we're in the positive x-axis, which means that x is negative 3 over 2, positive y-axis, so we have positive 1/2. So our coordinate here is going to be negative radical 3 over 2, positive 1/2. So we add that to our unit circle. For 150 degrees, we have negative radical 3 over 2, positive 1/2, which matches up with our second quadrant. Only sign is positive in the second quadrant. So we finished everything from 0 degrees to 180 degrees, and the 4 remaining angles, we can use the same rules for our 30, 60, 90 triangles. So you'll notice a pattern in your 30, 60, 90 degree triangles that makes it a little bit easier than doing this work over and over and over again. If your reference angle on these triangles is 30 degrees, then your ordered pair is radical 3 over 2, 1/2. So I'm going to write that down at the bottom here. If your reference angle is 30 degrees, you know for sure that your ordered pair is going to be radical 3 over 2, 1/2. That order is not going to change, but you have to remember and think about what quadrant you're in. The only thing that's going to change about these values is if it's positive or negative based off of the quadrant. If your reference angle is 60 degrees, then our ordered pair is always going to have 1/2 first. So if you have your triangle with a reference angle of 60 degrees, your ordered pair is going to be 1/2, radical 3 over 2. The sign is just going to change based off of which quadrant you are. So this makes it a lot easier than making your right triangle every single time, because there are a lot of values in this unit circle. This makes it a little bit easier to remember. So for the last 4 values in our unit circle, we're going to use this logic. So if we have our angle of 210 degrees. 210 is not divisible by 60, but it is divisible by 30. So that means our reference angle, which is here, is going to be 30 degrees. Our reference angle is 30 degrees, which means we're using the ordered pair radical 3 over 2, 1/2. So we know that order is correct. Now we just have to change the sign based off of the quadrant. In quadrant 3, the only thing that's positive is tangent. Our sine and our cosine are always negative, and our x and our y values are always negative. So for this ordered pair, our cosine has to be negative, and the sine also has to be negative. So cosine of 210 is negative radical 3 over 2. Sine of 210 is negative 1/2 sine. Sorry, not cosine. For our 240 degree angle, 240 is divisible by 60, which means that this reference angle with our x-axis is going to be 60 degrees. If we have a reference angle of 60 degrees, then our ordered pair is going to be 1/2, radical 3 over 2. And in our third quadrant, we know we're in the negative x-axis and the negative y-axis, so both of these coordinates have to be negative. So it's going to be negative 1/2, negative 3 over 2, which tells us that the cosine of 240 is negative half, and the sine of 240 is negative 3 over 2. And if ever you're having trouble with this logic, you can always just draw your triangle using the x-axis and figure out the sides based off of that. Now the last two angles in our unit circle, we have 300 degrees. For 300 degrees, we know that our reference angle with the x-axis is going to be 60. 300 is divisible by 60, so our ordered pair is going to be 1/2 comma radical 3 over 2. So now let's think about our x and our y. In the fourth quadrant, we're in the positive x-axis, so x is positive, and the negative y-axis, so y is negative, which means that the sine is always going to be negative, which is our y values, and the cosine stays positive. So for 300 degrees, the cosine is going to be positive 1/2. The sine is going to be negative 3 over 2. And finally, the last angle in our unit circle, 330 degrees. 330 is divisible by 30, but not by 60. So we know that this reference angle here is going to be 30 degrees. So our ordered pair is going to be radical 3 over 2, comma 1/2. In the fourth quadrant, we know that cosine or x values are positive, sine or y values are negative. So the cosine of 330 is positive radical 3 over 2. Sine of 330 is negative 1/2. And now we have completed this unit circle with all of our degrees and our coordinate pairs to tell us what the sine and the cosine of these values are. In Unit 3, we're going to move on to radians, which is why we have blank spaces throughout this unit circle. We're going to fill in the rest of this once we finish Section 3. So remember, for your unit circle, for any angles that are divisible by 90, they're going to fall on the x or y axis. So it's easy to use one of these four coordinates. You're going to have nice coordinates for those values, either 1, positive 1, negative 1, or 0. For any angles that you're given that are divisible by 45, you're using radical 2 over 2. The sign just might change depending on which quadrant you are in. If you're given an angle that is divisible by 60, your ordered pair is going to be 1/2 radical 3 over 2. Again, the sign is just going to change based off of which quadrant you're in. And if you're given an angle that's divisible by 30 but not by 60, you're using the ordered pair radical 3 over 2, 1/2. And again, your sign is going to change depending on which quadrant it falls in. Cosine of theta is always represented by x. Sine of theta is always represented by y. I know this is a lot of information, but the unit circle is very important. So your homework for today is just to copy down this entire unit circle and take a picture or scan it and post it to Classroom. Please, if you have any questions, feel free to contact me. It is extremely important that you understand your rules of special right triangles right now in order to label all of your sine and cosine of these angles. If you have any questions, feel free to ask. Good luck.